Alright folks, we're going to outline the function of a galvanic cell and then use half reactions to label a galvanic cell as well. So whenever we're talking about electrochemical cells, there's two different types. There's a galvanic cell, which is what we'll spend 90% of the time looking at, and then there's also electrolytic cells. So galvanic cells, you may see these called voltaic cells or a battery, but this is just some sort of apparatus that's generating electricity through some sort of chemical reaction, but it's a spontaneous redox reaction. So that means that delta G, so Gibbs free energy, is in fact a negative value, whereas an electrolytic cell is looking at a non-spontaneous reaction, which means that delta G is equal to some positive value. And we'll talk about these in more detail later. So let's go ahead and consider the overall reaction where we have zinc plus copper 2 plus forms zinc 2 plus plus copper. So what I'd like you to do is let's go ahead and try to write the half reaction for this. So we can write the half reaction by writing, well, we have zinc going on to form zinc 2 plus. All right, so is this process oxidation or reduction? Well, we can see that zinc is going from oxidation number of 0 to an oxidation number of +2, so it's losing electrons, so it's an oxidation process. So whenever we're writing out our oxidation half reaction, we'll put +2 electrons in the products. If we were to look at copper and assign the oxidation numbers, copper starts with a +2 oxidation number and ends with an oxidation number of 0. So the reduction half reaction is actually copper 2 plus. Remember that reduction is looking at gaining electrons, so the electrons show up in the reactants, and then the product is just copper. So if this is the overall reaction, what does this look like on an actual cell? So that's what we're going to try to look at today, and that's the main focus. So again, recall that the overall reaction that we're going to consider is zinc plus copper 2 plus yields zinc 2 plus plus copper solid. And we said that zinc was being oxidized and copper 2 plus was being reduced. All right, so anytime that we are going to try to draw a cell, we always want to show which way the electrons are flowing, and that will determine where everything else goes. So these arrows up at the top here, this shows the electrons are flowing from left to right. Okay, so as we look at our overall reaction, which one of these species is losing electrons? Well, it's the zinc, because we said the zinc was being oxidized. So that means that this here, and this represents an electrode. This is a solid electrode. This is zinc. Okay, so in general, we'll call these electrodes. Same thing over here, that's an electrode. So the zinc is losing electrons, and then what's gaining the electrons? Well, it ends up being that the copper 2 plus is gaining electrons. So this other electrode over here is copper. And then in solutions here, we have zinc 2 plus and copper 2 plus. And then to complete the circuit, we use this U-looking tube here, is called a salt bridge. And a salt bridge is just an electrolyte solution. So something that will dissociate into cations and anions. And a good general salt bridge that we'll use is sodium nitrate. So if we look at this, what we can see is zinc here is losing electrons. So that means zinc 2 plus is being released into our solution. Well, to balance the charge, the anions, so NO3 minus, is actually going to flow over here. And then the cations, Na plus, will flow over here because the copper is going to be gaining the electrons, and we're left with copper 2+. Okay, so it's being reduced. That copper 2+ is forming that copper on that electrode. So a few other things that I want to point out to you is for these problems we usually have some sort of voltmeter to measure how many volts is being produced by a chemical reaction. But there's a couple of fairly easy ways to know how to set these up. So the first thing that you want to do is you want to remember that we always show what's known as the anode. Okay, so this electrode's called the anode right here on the left-hand side. And then we show what's known as the cathode over here. And the anode gets its name because anions, so these nitrate ions, were attracted to this side. Whereas the cathode gets its name because the cations, so the sodium plus ions, were attracted to that side. So if you were to trying to figure out how to draw this, I like to think of it as my ABCs. So you have your anode, you have your salt bridge, and then you have your cathode. So see how you have anode, bridge, cathode. You have to know your ABCs. If that's not sticking with you, or if you're trying to figure out which one goes at the anode, is it the oxidation process or the reduction process? Well, remember we have NOx on this side, so this stands for, NOx stands for anode is oxidation. And then over here, we have a red cat, which means that reduction is the cathode. So if you can identify from your overall reaction what species is being oxidized, what species is being reduced, as soon as you recognize what's being oxidized, that's anox, so that goes at the anode, oxidation occurs, and whatever's being reduced is the red cat, and that goes at the cathode. So here's a brief summary of redox reactions. So at the anode, this is where oxidation occurs. This is where the electrons are produced, and the anions, hence the anode, are attracted for there, and we usually give this a negative sign. And then cathodes, this is where the reduction occurs. The electrons are consumed here, so the electrons are flowing from here, the anode to the cathode. Cations migrate towards this electrode, and it has a positive sign. So next time we'll start to look at a shorter way of labeling galvanic cells.